A single parameter inside an API request would have taken over an entire Postgres database. We found a critical vulnerability in ElectricSQL. It's a CVSS 10.0 vulnerability. We have a CVE attached to it as well. Let's take a look. So first things, I do want to say the ElectricSQL team has been phenomenal. When we reported this issue, they turned this entire thing in around 2 hours. So a really good job in terms of their response time. Now, let's talk about how we discovered this. We were doing a security assessment for a customer, and we identified that there was a SQL injection vulnerability within that customer's environment. We ultimately recognized that, oh yeah, ElectricSQL's API shape allowed us to pass in an arbitrary set of strings into the order by parameter. We can effectively inject any SQL statement into that order by parameter. So this is how their API surface looks like. It ultimately gets transformed into like a SQL select statement here, where you can select star from items and order by a certain dimension. Now, this is all good, but what if you pass in an arbitrary SQL statement into that order by parameter? It turns out ElectricSQL actually evaluates that SQL statement. So now you can stuff effectively any SQL statement into there and get it evaluated and start finding out information like looking at other database tables that exist on the system. And it turns out it also returns that error back to the user and actually shows you the results. So if you pass in this particular cast statement into order by parameter, it ultimately gets transformed into this particular SQL statement. So it will try to cast this bit into an integer, it will fail, but it will still evaluate the SQL statement. And the ultimate vulnerabilities here is that the user input flowing directly into the SQL statement here wasn't properly validated. Under the hood, there's the vulnerabilities in the parser level within the ElectricSQL database itself. When we look at it, before the fix, basically it first gets a request, it parses it into SQL, then it walks through the AST to ultimately try to figure out, okay, where should what statement be evaluated how, right? And it wasn't handling all the cases exhaustively. So it ultimately recognizes, oh yeah, if there's no particular case that gets matched, let's just handle it using a default mechanism, which ultimately led to an evaluation of that SQL statement. So that actual raw string then gets evaluated. It will actually say that there is an invalid input, but then also return the contents of that evaluated input. So that's where the real issue is. Now, after a fix, it's basically just checking for all the different cases that order by is supposed to handle. And if it doesn't handle that particular case, it will just throw a typecast error and not give you the underlying evaluated SQL and their responses to you. So it will not evaluate that SQL anymore. Ultimately, the impact here is quite dramatic, because if you have any sort of ability for a user to set how the data should be ordered by when it gets returned, you can actually put in any arbitrary SQL that gets evaluated on server side. There, for example, looking at other database tables, effectively breaking out of any constraints that you might have previously set in the where statement. And so through here, there's a few different scenarios we laid out that can be issues. One of them is certainly this data exfiltration thing. Other things, you can also insert new data, modify existing data, modify other companies' data. And then obviously also create like super user roles or additional user roles that persist over time there. The other thing about this is you can also call different functions that are specific to Postgres, like pgsleep, which ultimately will tie up the database connection and prevent you from making from other requests coming through. So ultimately, this does break any application level tenant isolation within ElectricSQL, but it didn't break the ElectricSQL's tenant isolation itself, if that makes sense. A user in one tenant could access, modify other tenants as long as they belong into the same database and the same application. So there's a proof of concept. It's basically just a few curl requests, so it's very easy to reproduce it yourself. And we also published this with the ElectricSQL team in conjunction. It has a CVE attached to it. You should read through all the details in here as well. And ultimately, I just want to highlight again the disclosure timelines here. So this vulnerability was persistent since October of last year in 2025. And then we discovered this vulnerability as part of a security assessment we've done in early April. We reported it obviously immediately to the Electric team because this is a critical vulnerability there. They fixed this within 84 minutes. and then ultimately deployed it across all the regions to all their customers within 125 minutes. So that's around the 2-hour mark, which is really, really fast response time. So great job to the ElectricSQL team. This is a good reminder how software changes so fast these days, so our security models need to adapt to it. Here's actually a good page I want to showcase here. It's the 0-day clock. And it basically talks about how vulnerabilities to exploitation time has shrunk dramatically over the last few years. So let's see, in 2018, it took about 2.3 years to really exploit a particular vulnerability. But in 2026, we're at 10 hours. And they're projecting that by 2028, it will be around a minute. So you really want to get ahead of this and perform always-on security testing.